right. We'll go from current slide. No, wait, I don't know how to do that yet. Sorry. Back off from that. I think where I need to go next is Blackboard. Okay. And you may not be able to see everything I'm doing. I'm in instructor mode, but it should be pretty similar. Okay. Well, if Blackboard will open, it's sitting there spinning its wheels. I keep inviting all the students to come to this, and I thought one was going to come today. He came Monday, and I said, well, there's a meeting. He said, oh, yeah, that's right, I got to go to that. And then he got lost and never made the meeting, so he went to... Really? And he didn't come in. Oh, yeah. Oh, was it someone from the physics class, maybe? Oh, I need to do that too. Sorry. Things I got doing, I'm not all together here. This, I hit the button and nothing happens. Okay. So anyway, let's go from here. Well, Blackboard won't open now. Now it says. All right. And Blackboard, hi. Here's the math team. This isn't how this normally looks. Well, they're not there. She said the questions were posted under Math Team. So let me... All right. Math Team members, meeting day, meeting day. Let's just see what this will do. Test, morning competition. Have you looked at this? Okay, you've been to the website. Have you found any of the... Let's just see if maybe it's here. Let me just look here. Okay, I'm not sure that's going to be helpful. I don't think that's helpful. Is it here? What's that?
The morning part is the calculus, and then
Right.
the afternoon
Oh, okay. Okay. Now, I'm going to go back. This thing is so terribly slow. Looks like I'm going to have to I'll open it back up later. This says right here, video solutions for 1 through 13. Let's just make sure that's the same one. It was a limit. I think it's the same one. Slideshow set up. Current slide. All right. Good afternoon. This is the math team reviews again. This time going over the inaugural Allomatic math tournament last Friday. Okay, was that right? Friday, yeah. Last Saturday. All right. Start at the beginning.
Okay. We don't have the answers.
Yeah, we don't have answers, so I'll make things up. Okay. That makes it better. Okay. Evaluate the limit. Yeah. The limit as x approaches a of x cubed minus a cubed divided by x squared minus a squared. Okay. That, I think, that, okay. How would you begin? Stop this if I can. All right. And then there's 14 to 21, 22 to 25. So you can go to those sites and see the first 25. So let's pick up with 26. Sound okay? So let's go back. All right. Where was it? Test morning competition. Okay. Okay, sorry it's taking so long. I don't know why it's so slow. So where did I say we start at 25? Okay. All right. All right. Okay. So here's what we'll do. is the best way to do this? All right, let's start here. Let me get my pen activated if it will activate. It won't activate. Yuck. All right. That's where I want to be. I need to get back to my PowerPoint. Okay, this is it. Okay. All right, can you jot this down? Suppose f of x, let me see, I can probably do it. From current slide. Okay. Now I can get my pen activated. All right. This is number 25. Okay. I wish I had two windows. F of x is equal to this is going to erase it all. This is such a pain in the neck. I don't guess there's any way I can copy this. Do you think there is? Let me see if I can. Because it won't let me write on this screen. And it won't let me copy that. Let me see about this. Yes, maybe. Well, that's enough. Okay, let's do a copy here. It doesn't let me copy. Yuck, what a pain. Okay, so could you jot this down? Suppose f of x is defined as follows. It's absolute value x for x less than or equal to negative 2. It's ax plus b for negative 2 less than x less than or equal to 4. And 3x squared plus 2 for x greater than 4. Okay? What I think I'm going to have to do next time is just print these. But my printer isn't working, so I can't do it now. Okay. All right. And, all right. So, and what we're wanting to do is find the values a and b so the f is continuous everywhere. Okay. So, let's go back to our PowerPoint and go from current slide. All right, so this is number 25. I've got to do this every time. So here's 25. F of x is defined to be absolute value x for all x's less than or equal to negative 2. It's ax plus b for all negative 2 less than x is less than or equal to 4. And what was the other one?
3x squared plus 2.
Plus what?
2.
2? Okay. For x, and it said greater than or equal to 4. It should be just greater than. One of these should not be an equal to, okay? But it really doesn't matter. We're going to make them equal to, okay? But really you shouldn't. You should only have one equal and the other one not equal. I mean, it's less than. All right. Well, not a bad idea to do a graph. So actually I should be on a graph one. So let me do this. Write them again. F of x equal absolute value of x for x less than or equal to -2. No, well, whatever. And ax plus b for -2 less than x less than or equal to 4. And what was the other one again?
3x²
X plus 2 for all x greater than or equal to 4, which really doesn't make a lot of sense, but it's okay. So, absolute value of x for all x less than or equal to -2, x equal -2, this will be -2. I mean +2 because it's absolute value. And -3 will be there. And so here is the first part of that graph, down to here. Okay? The last part of the graph, from x equal 4 on up. So let's do 4 first. 4 squared is 3 times 16. 48 plus 2 is 50. I'm not going to get it on this thing. So at 4, this is equal to 50. Okay. All right. So we have 2 points here. We have the point -2, 2, and we have the point 4, 50. Right? And we need a line that connects those two between -2 and 4. Right? So we have 2 points. We can calculate the slope, right? So let's do that. What's the slope? What's the definition of slope? Yeah, y 2 minus y1 over 2 minus x1. Okay? What you want your y2 to be? Yeah? 50 minus 2 over 4 plus 2. Yeah, minus a minus 2 is plus 2. So this would be 48 over 6. So that's equal to 8. The slope of that line is 8. So guess what the A is? A is equal to 8. Right? All right. Now we got to figure out what B is. Pick either one of those 2 points. I don't care which one. Okay? And we can say y minus I think it's easier to do it this way. Let's just do it this way. Y, that's your alpha of x, is equal to ax plus b. But we know what a is, that's 8, right? This will be the easiest way, I think, to do this. Okay? 8x plus b, right? Pick either one of those 2 points. -2, 2, or 450, I don't care. Pick one. Okay, -2, 2. Which is the x, which is the y? 2. Okay, so that'll be 2 is equal to 8 times -2 plus b. Right? That point's got to be on this line that has a slope of 8. Okay? So let's do that math, and it says 2 is equal to -16 plus b. B is equal to 18. And did you notice what the solution was? It was A is equal to 8, B is equal to 18. Remember? All right. Now, what a pain. What I have to do is go back and discard that and go back to this. We'll minimize this. All right. A is equal to 8, B is equal to 18. All right. 26. That's just for funsies. Okay. The slope of the graph of a function, f of x is equal to x cubed plus 3x squared minus 9x, is negative 9 at 2 points. Find an equation of the line passing through those 2 points. The slope of the graph of a function, f of x is equal to x cubed plus 3x squared minus 9x, is negative 9 at 2 points. Find the equation of the line passing through those 2 points. Well, what in the world? I'm so sorry I can't get this to right here. Okay, did you jot that down? Sorry about this. Okay, the function f of x equals x cubed plus 3x squared minus 9x. You got it. And you got the slope is minus 9 at 2 points. And what we're looking for is equation of the line passing through those 2 points. Okay? So let's go back to our PowerPoint. Okay. Go from current slide. Okay. All right, this is 26. So the function f of x is equal to x cubed plus x squared plus 3x squared minus 9x, and the m is equal to minus 9, right? Okay. Now, how do you get this? That's a y2 minus y1, right? Only now we got a function here, so your y's are f of x, and so let's call it f of x2 minus f of x1 over x2 minus x1. Okay? That's equal to negative 9. Okay. Here, I think is probably going to be the best way to, well, let's see. What is another definition for slope? Remember, this is calculus based. Yeah. What do we use for slope in calculus? Second? No, that's an integration. But it's the inverse of that, which is differentiation. F prime at some value x has got to be, and what is f prime? 3x squared plus 6x minus 9, and that slope has to be negative 9, right? Okay, well, let's add 9 to both sides. Okay, and that gives us that 3x squared plus 6x is equal to 0, right? Can we factor that? And that's equal to 0. Okay? So either 3x is equal to 0 or x plus 2 is equal to 0. So x equals 0, you'll have a slope of minus 9. Or at x equal minus 2, you'll have a slope of minus 9. Okay? Now, seems like to me, if you have slopes of minus 9 at each of those 2 points, then the line connecting the 2 points had better be, has to have a slope of minus 9, right? Let's think of that and see if that is indeed true. Maybe not. Well, so let's just see. What's the point where x equals 0? F of 0 is, what's the y value? This is going to be y2, let's call it. Yeah, that's going to be, plug it in, 0, isn't it? Okay, and let's do our y1. This will be f of minus 2. Where's that going to be 0? No, not 0. What is that going to be at that f of minus 2? So that would be minus 2 cubed plus 3 times minus 2 squared minus 9 times minus 2. Right? And that would be negative 8, right? Right. Plus 12 plus 18. And that would be 30 minus 12 is 22, right? Yuck. Such a pain in the neck. Okay. So at both of those points you have slopes of minus 9. But that doesn't mean because if you did the slope between those 2 points, that would be 22 minus 0 would be, or it doesn't matter which way you do it, that would be a slope of 11, I think, or minus 11. Okay, so that isn't a slope of minus 9. Okay, I didn't think that was going to necessarily work, but I thought let's give it a shot. Now the intermediate value theorem says that somewhere in between those 2 points, if the slope is minus 9 at each of those 2 points, let's just, I hate that I'm going to lose all this work. If you got this down, when x equals 0, y is equal to 0. When x equals negative 2, y is equal to 22. You got that? Okay. So, oh wait, no, I don't have to lose anything. Okay. So, x equals 0, 0. X equals minus 2, 22. 1, 2, 3, 4, 5, 6, 7. So let's see. 7, 4, 3, 6, 9, 12. Let's do 4. 4, 8, 12, 16, 20, 24. So there's 22 there, right? And sure enough, your slope here is a minus 9 here, and the slope here is a minus 9 here. Now, whatever the function's doing, we know those 2 points are on the function. Okay? Okay. Go back to here. Oops. All right. We know the 0.00 is on the function. Okay. Basically, what we're interested in it's not a very good way to do the problem, but what we could do is just start plugging in values. I don't know. Maybe an easier way. Let's try a few though. X alpha of x. Okay, we have 2 points already. 0, 0. Let me do them from a different location. Okay. Okay. We know at negative 2, we're at 22. At negative 1, we would be minus 1 plus 3 plus 9. So that would be 3 plus 9 is 12, minus 1 is 11. Okay. At 0, we're at 0. Okay, that means at 1, we're at minus 5, right? Two, we're at 8 plus 12 minus 18. Is that right? Yuck. That would be minus 2. How come what? I thought maybe that would help us. I don't know that it is going to help us. But I do know that I was just trying some things. And the reason I started there, we knew that derivative, let's just see what the derivative is, and that gave us two values. And I mean, we can go back and plug these. If we plug that in, obviously that's minus 9. When we plug this in, that would be 12. Minus 12, that would be minus 9. Yeah. So those two derivatives there are at minus 9. But we want, if I'm reading the problem right, we want 2 points whose the derivative between those 2 points is minus 9. Okay? This is the tangent line is minus 9. Have you got these 5 points? Negative 2, negative 22, negative 2, 22, minus 1, 11, 0, 0. Okay. Let's go back to our graph. There's that point, read a couple others to me. Now what I've done is my y, I did 4, 8, 12, 16, 20, 24, and 28. Minus 4, minus 8, minus 12, minus 16, minus 20, minus 24, and minus 28. And the x-axis is as it normally was. Okay? So give me those other 2 points. 3 points. Say it again. Minus 1, 11. Okay, that's going to be right about there. 1 and minus 5, that's right about there. 2 what? 2 negative 2? Okay, right about there. All right. Now, another thing we know is that this function starts low, goes up, comes down, and goes up, right? So obviously, the portion of the curve that we are dealing with here is this. Here it starts going back up again, okay? So somewhere over here, it was still going down. So the only place you're going to have a negative slope is in there. And we have a negative slope here, and we have a negative slope there, negative 9 slope. And I'm pretty sure that the mean value theorem says that somewhere in between those 2 points, I'm doing this backwards, the slope of the, if the tangent line is here, there's got to be a secant line somewhere there with the same slope, and we need the 2 points that would be the case. Okay? Anything over here is getting less negative. Okay? Yeah. Okay. See, the difference between these is negative 11. Okay? Difference between these are negative 11. Right? We want one with negative 9. The difference between these two is negative 5. So let's just do negative 3 for fun and see what we get. Negative 27 plus 27, right, plus 27. So that slope, this one up here for negative 3, would be 27. So you see it's less negative there, okay? So here the slope is negative 5, negative 11, negative 11, and negative 5. So something in between these two there has to be 2 points here and 2 points here where the slope would be negative 9. Let's try something. Let's just pick our x1 and f of x1 to be this point right here, 0, 0. And we're looking for so that says f of x2 is equal to minus 9 times x2. This is such a pain. We can even leave off the twos here. I think I'm getting close to having an idea what to do here. Okay. All right. We're looking for x and an f of x that's going to make that true. Okay? That the slope between that, we'll use 0, 0 as a fixed point. Okay? So, this says that x cubed plus 3x squared. This is such a pain in the neck. All right. I'm going to erase a bunch of stuff. Okay? Going to erase this and this. And probably that. Okay? All right. Okay, x squared minus 3x squared, plus 3x squared minus 9x, that's your f of x, is equal to negative 9x. Okay? That's from this, okay? We're picking some other value here that has a slope of minus 9, but it also has to be on the curve. Okay? And if it's on the curve and has a slope of minus 9, we'll use 0, 0 because you know that one's on there. So this function with that x value, it's got to equal minus 9x. Okay, from there. So I think we're right at getting it. Add 9x to both sides. Okay? Those go away. And you get x cubed plus 3x squared is equal to 0. Well, factor out x squared and you get x plus 3. Right? Well, you know that when x equals 0, yeah, we know that one's going to work. But it looks like here that x equal minus 3, that may work too. And sure enough, does it? Yeah. Well, yeah. Because you see if you go from 27 to 0, that's a change of 27. Negative 3 to 0 is a change of negative 3. That slope is negative 9. So that's one of the points. X equal negative 3, y is equal to 27. And 0, 0. Okay? Let's go back and see if that's the answer. I hate it because I'm going to lose this. But, okay. So, negative 327 and 0, 0. Find an equation of a line passing through those 2 points. I'm sorry I didn't do the whole problem. Okay, let's go back to our PowerPoint. Okay. Okay, we know the 2 points, 0, 0, and negative 3, 20, what? 27. Okay, yeah, that works. All right, we know the slope already. M is equal to negative 9, right? 27 minus 0 is 27, divided by negative 3 minus 0 is negative 3. 27 divided by negative 3 is negative 9. The slope works. So let's pick this, okay? Y is equal to minus 9x. That's it. It goes through 0, 0. It goes through 327, negative 327. That's the equation of y. Right? So, That should be the answer. Y is equal to negative 9x. Okay. Minus 11x? I do not believe it. What's that?
Wasn't that what we got the first time when we did the derivative? Because you said it was 11.
Yeah, I've lost that one. But that's not right. I mean, that would have to go through the origin, and that would be 0, 0. The slope, well, I mean, obviously it's not right. Find an equation of a line passing through the 2 points. Wait. I misread the problem. The slope of the graph of a function, blah, blah, is negative 9 at 2 points. Oh! You're right. I did it the first time. I wish I could look at the problem. The slope of the graph of a function of that is negative 9 at 2 points. And we found those 2 points. Okay? Find an equation of the line passing through those 2 points. Not the two. Yeah, you're right. We had that the first time. I misread the problem. Sorry about that. Because our 2 points were 0, 0 and negative 2, 11. No, 22, exactly. So, yeah. Yeah, you're absolutely right. We had that to begin with. I misread what the problem was asking for. Sorry about that. Okay, so we had the 2 points, 0, 0, and negative 2, 22. Is that right? Okay, these. Okay, obviously the slope of the line passing through those 2 points is 22 over negative 2, which is negative 11, and it passes through the origin, so it's going to be y is equal to minus 11x. Yeah. I'm so sorry. I missed not being able to look at the problem. I thought it meant find 2 points who have that slope of minus 9. But I'm sorry. That was just, okay. Let's move to the next one. This is a terrible way to have to do this. Okay. Oops. Find the volume under the surface. Z is equal to y sine x over the rectangle. 0, x is between 0 and 2, and y is between 0 and 1. Find the volume under that surface within that rectangle. Got it? Okay. Now, that's going to be a what? Okay. We're looking for, okay, name that rectangle again. Okay, say it again. Y sine x. Oh, that's the surface. Okay. Oh, okay, you didn't get that down? Okay, let me go back. It's not going to take long to... Okay. Okay. Z is equal to y sine x. X is going 0 to 2 and y is going 0 to 1. Got it? Okay. So let's go back to this. Okay. So, so z is equal to y sine x. Okay, is that it? And you're doing the rectangle 0 less than or equal to x less than or equal to 2, and 0 is less than or equal to y is less than or equal to 1, right? Okay. Now, you're in Cal 3 right now. We haven't quite gotten to do this yet, but what we've got, what this is a integral with multiple variables. Okay? Right. And what is your volume under that, within those things, is going to be, and you can do the order either way. Let's first do it this way, 0, 2, and if it doesn't work out, we'll change it. That's the x part, and the integral 0, 1, no, I'm sorry, that's the sine x part. Okay, and this is y, and we're going to do dy first and dx second. Okay, in other words, we're integrating that function z over this. But since this has no y dependence, we can pull that out for the x integral. So we're going to integrate this one first. Okay, and we do them separately. We'll do this integral first, and this will be the integral from 0 to 2 of sine x, and what's the integral from 0 to 1 of y? Huh? No. Antiderivative of y. Y2 over 2 evaluated from 0 to 1. Okay? And then we'll ultimately have a dx there. Okay? So let's do that first. It's the integral from 0 to 2 of sine x. And what does this term come out being? 1/2, right? So we'll just pull that 1/2 out here, dx. Well, what's the antiderivative? This is 1/2 of antiderivative of sine x is negative cosine x. I think we have a pretty big problem here. Oh, no, that's fine. Okay. So we'll pull the minus out here. I'm sorry. I don't need the integral sign anymore. Pull the minus sign out in front, and we'll be evaluating cosine x from 0 to 2. Okay? And that basically is going to be minus 1/2 cosine 2, and cosine 0, of course, is 1. Okay? Now, if you got a calculator, be in radian mode and see what cosine 2 is. Now, they may leave it in this form right here. Let's just write this down for now. 1/2 times 1 minus cosine 2. Okay? And you can calculate that if you want to. That's probably a little easier calculating that way. It's what? Negative 0.42. Okay. So that would be 1/2 of 1.42. So that would be approximately 0.71. Okay. let's see what kind of answer they give. Okay? You got it down? All those forms. 1/2 of 1 minus cosine 2, that may be how they put the answer, or they may do it something like 0.71. It's multiple choice, so we should see what we can get. Okay. Let's see what we get. 1 minus cosine 2 over 2. That's what we had, right? Yeah, so that's the answer. They didn't approximate it. Okay. And the good news is they come out a positive quantity. And we wanted a positive quantity because that's the surface. It's obviously positive, okay, above the XY plane. So yeah. Okay. 28. Evaluate that definite integral. Okay. Got it down? Negative integral from 0 to -4 of square root of 16 minus x squared dx. Got it? All right. Let's go to our PowerPoint. Okay. Get my pen back. Okay. This is what, 27, 28? 28. Okay. It was the integral from 0 to -4 of the square root 16 minus x squared dx. Okay. Oh, it's the minus integral of that too, wasn't it? Got it. Okay. First thing I'm going to do is flip that over. Okay. And make it positive the integral from -4 to 0. Right? If you change the limits, you negate it. So now we don't have to worry about the minus in front. Of the square root of 16 minus x squared dx. Okay. Now, no substitution here. This is one of those trig. Okay? You think Pythagorean theorem. Okay? This is 4 squared minus x squared. Now, this trig substitution would be let x equal 4 sine theta. I'm pretty sure that's going to be it. If not, we'll change that. Okay? Well, let's just see how that pans out. X squared would then be 16 sine squared theta, right? And 16 minus x squared would be 16 minus 16 sine squared theta, right? Right. Then if you put that under a square root, you have, factor out of 16, square root of 16 is 4, and you're left with 1 minus sine squared theta, that's cosine squared theta. Square root of that is cosine theta. So what's in there is your cosine theta. Okay, there's that. Then, dx is equal to what? Four times cosine theta d theta, right? See that? All right. Is that someone coming in? All right. Are you here for physics?
Yes, sir.
Dr. Bryant is sick.
Oh, he's not here today?
No, he's not here today.
Oh, okay.
I'm so sorry. I asked him if he sent anything on Blackboard. He said, I haven't even gotten to a computer yet. He really sounded bad. Yeah, okay. Sorry about that. Okay. So, the other thing we've got to do is, let's figure out when x is -4, right? What is theta? So when x is -4 is equal to 4 times the sine of some angle theta, that means theta has sine theta has to be -1, right? And what value of theta would give you a sine of -1? A sine of what angle theta would give you a value of -1? No, pi is 0. Second? Okay. Think of your sine function. It goes up at pi halves, it reaches 1, right? And then it's 0 at pi. And then it goes down to -1 at 3 halves pi. It's 3 pi over 2. Okay. So that would be at 3 halves pi, or you could take it at minus pi halves. It would be a -1 there too. So I'd say let's take it at minus. So this is going to be, and then where is, when x is 0, that would be, theta would be 0. So I think we're going to have a 0 here, and I don't know which I want to use. I think I want to use negative pi halves here. Okay? Now let's put in our square root of 16 here for physics.
Yes.
Yeah, Dr. Bryant's sick tonight, so he's not going to be here. You here for physics?
Yes.
Yeah, Dr. Bryant is sick tonight, so he's not going to be here. Yeah, we're doing math team. Yeah, it's not physics class.
Okay.
Yeah, so if you want to stay for math team, you can, but do you?
I didn't even know there was a math.
Yeah. Yeah, you want to participate?
How long? For how long?
Well, the competition is on
It's just
one competition, October the 6th or 7th? 7th.
I'll work like full-time student, full-time
Okay.
employee.
I see.
I'll work every single Saturday, 12
Okay.
hours a day.
Okay. Well, if you want to just see what the
Yeah.
the
Yeah.
the stuff is like, you can. Certainly welcome to be here. Did you want to see it too? I'm not doing physics class. Dr. Bryant's sick, so he's not going to be here today.
So
we're-
my class is completely canceled for today?
Yeah, his class. He said he had stuff out there on Blackboard. You can
Yeah,
do
I mean,
working on.
we had some like labs, right?
Yeah.
And we have our labs and stuff.
Yeah.
So there's no, like, you're not the substitute teacher teaching.
No.
Okay,
Yeah.
so class is completely canceled.
Yeah. He.
That's weird. I get all my emails from my phone.
Well, the thing is, he wasn't at a computer, so he couldn't send anything.
Oh, okay. Yeah.
He said write it on the board. So I said I'll write it on the board in that room, and we'll be in this room to tell students when they come by.
Usually there's a lot more students here. Like,
Yeah, well, a few have already shown up.
Oh, okay. You've already shown up and gone. Okay. Because class usually starts in like at 4:45.
Yeah.
30 minutes.
Oh, yeah.
Wow. Okay.
But after this one,
We can stop. Okay.
I had to eat today.
Okay. Sorry about that. All right. So let's do it from negative pi halves to 0. And our thing will be 16, because you got 4 times 4 is 16, cosine squared theta. Okay? D theta. Okay?
Yeah, he's sick. Class.
If you remember Monday, he didn't sound too good.
No, yeah.
Yeah, and he's much worse today. When he called, he sounded awful. Huh? I'm sorry.
You know what it is? Like, what's wrong with it?
It's just a cold, I hope. Yeah.
Man, cold.
It really was. I mean, he may even have the flu.
Yeah, I know. It's not off work. If I had
I'm
a
sorry.
job from Irondale over here.
I'm
It's like,
sorry.
Man, dang it. Like, I check my email all the time.
Yeah.
It's like I get
Well, I asked him if he put it on Blackboard. He said, I can't even get to a computer right now.
Yeah.
So,
Okay.
And those are removed because I'm in the class.
Right.
so yeah, there's still people showing up then. So when we knock this off, I'll put it on the board so everybody will see. I'm sorry we couldn't get you the word earlier. I guess he called me while I was in class. I just happened to stop by the office and picked up the phone, and I didn't have an opportunity to send anything out. I thought he was going to try to get to a computer, but evidently he didn't. Wasn't able to, because he sounded bad. Yeah, you here for physics?
Yes, sir.
Dr. Bryant's sick.
Class is canceled.
Sorry about
Is
that.
okay? Yeah, I'm sure he's just got cold or something.
Do you remember Monday? He didn't sound good at all. Oh, you were? Huh?
I wasn't able to make it Monday.
Oh, I see. Dr. Bryant's sick, so there's no physics tonight. Sorry about that.
Yeah, everyone's like, dang, we just drove all the way out here. You know, or like, yeah, yeah, I just came from Irondale, like a good 35,
sorry.
40-minute drive from my car.
I got clay.
And plus, it's like, we got to get here right on time, because
Yeah.
he starts class and he just rolls with it.
Yeah.
Yeah.
So you is okay. You said you was there all day, right?
Yeah.
So you just
And
an early release, you just like.
Here's something that I taught physics this summer. We didn't cancel many classes, but I know the students sort of got grouped together and sent messages to each other. So I mean, y'all may consider doing that, and then the first one who hears can send it to the whole group. In case he can't get to a computer. Yeah, so I know they did a good job of that. 'Cause they were ahead of me most of the time. Yeah. Okay. Here for physics?
Yeah, under the lab and content.
Yeah, but I can't, it won't open up. I have to go.
Yeah, for me, I have.
Are you here for physics? Yeah. Dr. Bryant's sick.
I'm using the work on
So he's not gonna be in.
What's
What's that?
You gonna teach us?
No, his class is canceled. I was just doing math team practice. I'm sorry. He wasn't.
Question about the
layout. How we do the
I was gonna say.
Okay.
This the easiest one to do. How you do the force and motion layout?
You gotta use Java, you gotta download Java.
No, mine work, but I'm saying on getting. Yeah, on
I do the
getting.
calculation, then I input the.
Maybe we're through.
But no, not the one.
See if you
where
can
you
get that integral to work out, and if so, see what you get.
Pushing